So in this presentation, we're going to look at set theory stuff. And what we have here is, let's see now, draw a labeled Venn diagram depicting ABC. These are three events. These are three subsets of the universal subset U. In such a way that they divide U into 8 disjoint regions. So let's do that first off. And what I'm going to go and do is I'm going to go to the next slide here, which should be blank. There we go. Now, so what I'm going to do is actually just first off draw the universal set. And the universal set is depicted as a box diagram. And I'll actually try to use a straight line as much as possible. There we go. So this is U, and that is the universal set. So everything that is in the universal set is in the boundary of this rectangle. Now what I'm going to do now is draw regions A, B, and C, or subsets A, B, and C. So I'm going to draw A. I'm going to draw B. And let's put it in green here. C. Okay. Now, what does that mean? Do I have 8 disjoint regions? Well, let's put that back in A, B, and C. Let's sort of label them a bit better. Now, do I have 8 disjoint regions? Well, let's work from the inside out, and let's just give each of them little, let's call this region 1, let's call this region 2, 3, 4, 5, 6, 7, 8. So we have 8 with the rectangle around the corner and the 3 circles. We can divide up the universal set into 8 distinct regions, and there they are there. So that's that part done. Now the next part of the question is, this is the subset X, and it's a subset of U, and it's defined with the following membership table. So what we have to do is depict it on our Venn diagram. Okay. Now, so U is, or this region X. What we have to do is find where we have a 1 here. Okay. So there are 4 regions where there is a 1. Let's highlight this. These regions here. Now, with regards to what we've done already, let's look at the corresponding values for A, B, and C. Now, 0 means not within the boundaries of A, and 1 means within the boundaries of that C. So 0 for A, not within A, not within A, not within B, but within C. So this is like, you could sort of say C only. So let's go back to our diagram here. So which region here corresponds to being within C but not within A and B? Well, clearly it corresponds to this region here, what I have written as region 7. Now I might have to sort of fix up my boundaries as I go. There we go. Or fix up my Venn diagram as I go. So the first region is region 7. What I have as region 7. It's within C, but not within A or B. Okay, so it corresponds to that region there. So we've got three more of these regions. We have A only, but not B and C. So this is pretty similar. We're just going to do it for A here. And there, this one here. This region here. That corresponds to region 5. As what we see there. With two more. And we have this one here now. 101. So it's within A and it's within B, but it's not within. Sorry, it's within A and within C, but not within B. Likewise, this is within A and B, but not within C. So what regions correspond to being within A, within B, and not in C, and similarly A and C, but not within B? So it's these intersection regions here, just beside the intersection regions, this one here, region 3 and region 2. Now, just I'm going to just sort of put in my Venn diagrams again, or my boundaries again, just to sort of make them a bit clearer to look at, and then we can go back and just sort of have a bit of a discussion about that. So region 2 there, just here, is within the boundaries of A, it's within the blue line, and it's within the red line, but outside the green line. Okay, so it's A1, B1, and C0. And likewise, region 3, it's within A, it's not within B, and it's within C. So it's 1 for A, 0 for B, and 1 for C. So that's 3 there, and that's 2 there. My regions 3 and 2. Okay. Now, that's just a bit of spill over there, that bit there. So that is our shaded area. What we have to do now is try and describe it as best we can, using the most simple notation we can. So together, what I'm going to do is actually sort of split it up into two parts. So the first part is, I'm going to just pause this a second, just so I can reuse the diagrams. So what we're going to do is actually try and sort of express it as two parts together. Now, what I'm going to do first off is I'm going to sort of say it's the union of these following regions. So I'm just going to sort of recolor one of them here, or actually I'm going to decolor one of them. I'm going to get rid of the white here. Just sort of set that back to normal. So that was, what we were looking at there is regions 2 and 5. That was 3, oops. That was 3 there, that was 7 there. So region 2 and 5, particularly this region here, okay, that's the one region we're going to look at. That's 2 and 5, regions 2 and 5. That is also the set difference of A and C, or A minus C. Okay, that's regions 2 and 5. It's this shaded region here. Let's go to the other one here, and what we're going to do now is color out this region here, just so we're left with regions 2 and 5, or sorry, 3 and 7. So regions 3 and 7, that similarly, in a similar sort of way, that corresponds to in a similar sort of way, that corresponds to 3 and 7 corresponds to, this is C down here. Circle the set C. That corresponds to, this shaded region here corresponds to C minus B. This shaded region here. Okay. So that one there is A minus B. This one here is C minus B. Together, what we have there is A minus C union C minus B. Okay? And that's as simple as we can get it, really. You probably could come up with some other answers. But anyway, that's the end of this presentation.